Do you feel the vibes?
All right, so let's talk about scatter plots. A scatter plot basically shows the relationship between a set of data with two variables, okay? And they're graphed as ordered pairs in a coordinate plane. So scatter plots are used to investigate a relationship between two quantities. They can have a positive correlation, a negative correlation, or no correlation. And you can see here, right, a positive correlation is something that looks like this. Now, not all the data points lie on a single line, but in general, you can see that there is like a trend, increasing, right? And then with a negative correlation, you can see that there is a trend going down or decreasing. As opposed to this last one where the data is really all over the place and there doesn't seem to be a trend in any direction, all right? So here, determine whether there is a positive or a negative correlation. Well, in this case, it's a positive correlation, right? Describe the meaning in this situation. So let's take a look at what this is. This is an example where it's so important that shows you how important it is to label your titles, right? So for example, look, this is wages, right? And here you have wages in dollars graphed against hours. So, you know exactly what this is telling you, right? So the more hours somebody puts in, the more wages they're basically earning, right? So the more you work, the higher your wages will be. Okay. So scatter plots can show where there is a trend in a set of data. And when the data points all lie close to a line, we can create or come up with a line of fit that can model the data, and it'll be like a good estimate for us to, predict points. Okay, so how do you make a linear function model? All right. Oh, sorry. Okay, so first you have to make a scatter plot and determine whether there is any relationship. Next, draw a line that seems to pass close to most of the data points. Use 2 points on the line of fit to write an equation for the line. And then use the line to make predictions. Okay, so take a look here. This table shows the largest vertical drops of 9 roller coasters in the United States and the number of years after 1988 that they were opened. Okay, so identify the independent and dependent variables. Is there a relationship in the data? If so, predict the vertical drop in a roller coaster built 30 years after 1988. Okay, so first let's figure out the independent and the dependent variables. So which of these, years since 1988 or the vertical drop, would you say is the independent variable? And then which is the dependent variable? Yours is which one? Yours is the independent variable, right? And remember, the independent variable always goes on the horizontal axis. And then the dependent variable is the vertical drop. That always goes on the vertical axis. So this is the vertical drop. In feet. Okay, let's plot these points. Okay, so 1 year after, the vertical drop is 151. That's got to be super close here. And 3 years after, it's 155. 4 years after, no, 5 years after, it's 225. 8, 230. 12, 306. Okay, that same year, 12 years after, another one was built. That was 300. So these, we need to have two on top of each other. And then there was another one that same year, 255. Wow, that was a popular year for roller coasters, right? 13 years after, there was one at 255. And then 400 feet. Right? Okay, so what do you think? Does there seem to be a positive or like any correlation? There is definitely a positive correlation, right? So what you want to do now is you want to draw a line through this. The line has to be so that, make it so that like it's kind of evenly through the points. So about half lie above the line, about half lie below the line. All right. So what I'm gonna do is I'm gonna have my line go through those 2 points. All right. So let's do that. Here, you can take a ruler. Okay. And once you identify 2 points, so we know there is a positive correlation. What are the 2 points? We have 3, 155, and the other one is 12, 300. Okay, you can write an equation that goes through those points, right? Find the slope and so on. So what would the slope be? 300 minus 155 over 12 minus 3. That's 145 over 9, 16.1. So I'm going to use this point to write my equation. Y minus 300 is equal to 16.1 x minus 12. Why did I use that one? Just because? Did it matter? No. So y minus 300 is 16.1x minus 193.2. So y is 16.1x plus 106.8. All right? Yeah. Now, the next part of the question says, if so, predict the vertical drop in a roller coaster built 30 years after. So if this trend continues, what's going to happen? Well, y of 30, that's going to be 16.1 times 30 plus 106.8, 589.8 feet. Cool? Very cool. All right. Okay. So the table shows the media age of females when, oh, I think that should say median, not media age. The median age of females when they were first married in these years. Okay. So let's see if there is a relationship here. Make a scatter plot and determine if the relationship exists. Identify the independent and dependent variables. So what do you think? What would be the independent on the horizontal axis? The year, and then the age. Okay, so let's go ahead and plot these. Okay, so once you graph it, it looks like that. Okay, so first of all, do you see a correlation? Do you think there might be a correlation? Yes. Okay, so that last point over there, that looks like it's an outlier. You know what? Why don't we check to see if it is an outlier? What would be the median here? It's the 2001, right? That's Q2. So Q1 is 25, this one, 1998. And 2004 looks like it's Q3. So let's quickly do the interquartile range. That's Q3, 25.3 minus 25.0, 0.3, right? And then if I do 1.5 times 0.3, how much is that? 0.45. So 25.3 plus 0.45, how much is that? 25.75, is that right? Yes? Okay, so do you see how that last one is definitely an outlier? So in this case, what I'm going to do is I'm just going to ignore it, right? So just ignore it for your best fit, and let's do a line through these points. So I'm going to make it go through these points here, right? Yeah. Okay, so let's do this. I guess not. Like there are ways, but right now, if I do this, it goes through more points. Just make sure you have like an equal number above and below. All right. So the points I'm gonna pick are 2000 and 25.1, 2003 and 25.3. All right, and I'm gonna give you so like 2 minutes to come up with this equation. All right, y equals mx plus b form. On your mark, get set, go. What I have 0.07x minus 114.9. Yes? No?
Well, I didn't round it to 0.07. I did 0.067.
Wait, 0.067. Oh, okay. All right, so if we go with this, what would the median age of females be when they were first married in 2022? Right? What would you do in this case? So 2022, how many years after is that? 20, how many? 26. 26 years, right? So this would be y of 26. This is minus, not equal to 0.07 times 26 minus 114.9. What do we get?
Why 26?
Because it's in 2022, and our story begins in 1996. That's right, 26 years after. So what do we get for this?
Negative 113.
Oh boy. Huh? So 26.6, we have to use the actual date. And so here, so this is y of 2022, not 26, sorry. And then here, do you think the equation can give a reasonable age for the year 2056? What do you think? 2056. I mean, we don't know by then, right? Like it looks like like the correlation I think is way too far to do that, right? So I think we would need like more data to do that, because this is such close data, right? Just like 20 years, and then to go 50 more years, that's like, that's a little bit more. All right, so that's it for today, and I do have a worksheet for you.
Press